Hi, welcome to my video on domain and range of a linear relation from a graph. Domain and range from a graph. Recall, domain is the x values, range is the y values, and the ordered pair is x, comma, y, and domain is x, range is y. So notice, if you do the alphabet, X is before Y, D is before A. That's the way I remember when I was starting out. So let's do some examples. Find the domain and range of each. So when you look at a graph, you pick up, the domain is the X values, so you pick up the -1, you pick up the 1, and this point has a 3. And they're in order, so everything is okay. Put them in order. It's easier to see when you have them in order. So there's the domain. The range is the y values. So the y values, if you start up at the top or come down, so y values are 2. And you come down to the next one, the y values is 0. And the y value on this one is -2. So if you put them in order, then the y values are -2, 0, 2. And putting them in order is easier to see, and the teacher would like to have them in smallest to largest ascending order. B, domain is x, and the values of x in this is easy to see. We go from smallest to largest, so it's notice it's -2, -1, 0, 1, 2. So that's the domain, or the values of x, done. And the range is the y value, so the y on this point is 2, y is 2, y is 2, 2, 2. So the range is 2. Remember, the range is the y value. I'll keep stressing that. Domain is the x value. In this graph, now we have all the values. These are real numbers, so we have all the shading between on this between this point and this point. So this point is included, solid dot. This point is not included. So if you look at this point is 1, x is 1, y is 3. And if you look at this point right here, x is 3, and y is 1. Okay. Just a coincidence I have them reversed. So the domain are the x values. The x values go from 1 to a 3. 1 right here to a 3 right there. So it's a 1 to a 3. So 1 is less than x less than 3. And the 1 is included because of the solid dot, and the 3 is not included because of the hollow dot. So we can write 1, 3 if we want to do the interval notation, and the 1 is a square bracket is included, and the 3 is that bracket, not square, means it's not included. So let's look at the range. The range are the y values. The y values right here is 1, and it's going to a 3. So it's a 1. Just a coincidence that the two of them are the same. So the range is the y values, less than, and the y value is not included of 1, but the 3 is included. Not included. I put a bar there. Not included. So the 1 is not included, so there's no equal sign. The 3 is included, so I put the bar. The bar means the number is included, the point, the coordinate of that point is included. So that's a 1 and a 3, and it's a circular 1 that's not included, and the square 1 is included. Just be careful. Remember, neither the 1 nor the 3. The 3 for the x is not included, and the 1 for the y is not included, just to make sure. and D, we have both points included. So this time we have this point right here, x is 1 and y is 0, and this point x is 2 and y is 3. Okay, we have the points. So the x values go from x is 1 to x is 2. So they go from a 1 to a 2. X in the middle. 1 is less than x, less than 2. And the 1 is, this point is solid. This point is solid, so there's 2 bars, meaning 1 is less than or equal to x, less than or equal to 2. And so that's 1 comma 2 and 2 square bars because the 1 and the 2 are included. And the domain is x, the range is y, so the y values will go from, the x values go from, like looking here, the y values go up and down, so the y values are 0 to a 3, so 0 to a 3, we're talking about the y's. 0 is less than, 0 is less than 3, so we put less than, and 0 is solid, and the 3 is a solid point, 2 solid points, so that's equal to with the bars, and so we have 0, 3, square bracket, meaning the 0 and the 3 are included. Notice. Okay, now we got more samples. The more we do, the better we get, or the more we listen and observe, the better we get, and then we got to practice. Find the domain and range of each, and we have the domain and range. Okay, let's put domain and range. I didn't put it in here, but here we go. The domain are the x values, and so the x values is, this point right here, x is 0 and y is 1. So the x values start off at 0, so x is starting at 0, and the x is going to the right. As you draw this line, the x values are going out this way, so the x's are greater than 0. Because it's solid, we say equal to. So that's the inequality. And we do, this starts at 0, so it's a square because 0 is included. And we go to positive infinity. That is a hollow, that's a round bracket. Show that when you go to infinity, negative or positive, you have to use not included because it never ends. The range is the y values in this graph, and the y's start at 1. Notice y starts at 1, and the y is going up, so up is positive. So it's, notice the y is 1, 2, as you go out, the y is 1, 2, 3, 3 is over here, 4 is over here, 5 is, as the line goes on out. The y's are greater than, and it's an equal sign, so it's a bar. And it starts at 1 and it goes to positive infinity. That's where the y is going to, because the y goes up and up and up forever. And the x's go to the right forever. So positive infinities. And it's a square bracket because this point is solid. F, again we have a domain and we have a range. Domain is x, range is y. So this point right here, the x is -1, and the y on this point is -2. So the x's are starting at -1. So it starts at -1, and the x's are going, if it went to the right, it would be greater. If it went to the left, is less. So this is, as we go up, the x values are getting -2, -3, etc. So it's less. And there's no bar here because that's a hollow dot, is not included. And the interval notation for that is -1. So we can go -1 going to negative infinity, or most people probably would go -1 on this side and negative infinity. So this might be, I'm not sure, which is ask your teacher, if you put the -1 here going to the left, or this means the same thing, only it looks like you're going to the right because it's swinging to the right. But either one of these could do. But this one is preferred. And the range is the y values, and the y values start at -2 and go up. So the y values start at -2. Going up is positive, so it's going to be greater. And there's no square bracket, no bar, because it's hollow dot. And it's positive, so it's round, -2, and it's going up, so it's positive infinity. Infinity is never closed, no square bracket. It's a curved bracket goes on infinity, show that it's always open. Again, the y values are going up. Notice -2, -1, 0, 1, 2, 3, etc., etc. So that y is going to infinity. And G, we have a domain, we have a range. Domain is x, the range is y, always. And notice the domain here is x, is a vertical line, so that's a 1. So that's a 1. X is 1 there, x is 1 there, x is 1. So the domain, there's only one value for the domain, which is 1 for x. And the range is going up to include all the positives. It's all going down to include all the negatives. So the range is y belongs to real. So it's including all the numbers that's y. 0, 1, 2, 3, 4, and -1, -2, -3, -4, etc., etc. And so how do we write that in interval notation? Well, if you want to write them all, you go negative infinity to positive infinity. That's how you write all the real numbers. And YER means all real numbers. So all the y's are real. And H, we have a line slanting with a positive slope. And notice as you go up, you're going to take the x's on the right. And as you go down, you take the x's on the left. So the domain for the x's, the domain is XER, has all the reals. And we have negative infinity going to positive infinity for real numbers. And also, notice the y's as we go up, we're including all the positive y's that way. And as we go down, we're having all the negative y's. So the y's are also all the reals for the domain, so for the range. And so they write that the same way, negative infinity to positive infinity. That means it's open. So we're including all the negatives and all the positives, all the real numbers. So the line that is drawn going on in both directions has, this line that's oblique, has real numbers for the x and real numbers for the y. Okay, practice. Practice means pause the video and work out the answers. Find the domain and range of each. And we're graphing on the real numbers. The domain values are the x values. Okay, the x values right here that start on the left. X value is -1. The x value as we go here for this point is 2. And the x value for this point is 3. And the range is the y values. So what y values do we have here? Well, we go from the smallest to the largest. We got this point, this point, this point. The smallest y is -2. The next y is 1. And the next y is 3. So that's the domain and range. And we have a bar. Notice this point is included and this point is not. So this point right here is 3, 2. This point right here, x is -2. X is -2, y is -1. So the domain is the x values. So the x values are going from -2 to a 3, going from -2 to a 3, where you can look at the x's in the point. -2 to a 3, x is in the middle, less than. This point is solid, so that's equal to, this is a bar. This point is not solid, so it's hollow. And so we don't put any bar on it, it's not equal to. And that's a 2 to a 3, and that's an equal sign solid, so that's a box, and this is open. And the range is the y values. The y values go from a 2 and -1. So the smallest is -1. The largest is 2. So we go from -1 to a 2. And it's the y values, less than. -1 is included. So it's an equal sign. And the 2 is not included because it's hollow. So that's a solid on the -1. And the 2 is open. So -1 to a 2, and it's included, not included. Remember, the domain is x, the range is y. Number 3, domain and range. Let's see. We have a array again going in one direction. So this point here, x is 1, and y is 0. X is 1 right there, and y is 0. So that's the coordinates of that point. So that means domain is x, so we have going in one direction. We have x, and x starts at 1, and the x is going, as we trace this out, the x's are going to the right. So it's greater than 1, and it's equal to 1 because of the solid dot. So that's a 1. Solid is the square bar, and we're going to positive infinity. Put it open. The range is the y. The y's start at 0. And the y values on this ray, the y's are going down. So the y's are less than 0. And it's a solid dot, so it's an equal sign. So we put the bar. And so this starts at 0 and going down, so we can go this way, 0, and going down is negative, so it's negative infinity. Or some people might say, well, let's put it starting at 0 and going to negative infinity. So you can have that or that, it makes no difference. Makes no difference. So you go from 0 to negative infinity, but don't make any difference as long as you read it. Again, if you put the coordinate of the point 1 and 0 first, then this goes from 0 to negative infinity, which means look on the graph, it's going that way. So we might want to scratch that out and always put the coordinate of the point starting it off. Might be better. Okay. Number 4, we have domain is x, range is y. The domain is, notice all arrowheads going like that is a horizontal line. So that's, domain is all the real numbers. And we do that by negative infinity to positive infinity with open round brackets. And the range is y is just 1. Only one value for y on all those points. Remember, this goes on and on forever. So that's why all real numbers are here. Number 5, we have a line that's negative slope, but this line has all the x's. So as the line goes down, the x's are going this way. As the line goes up, the x's are going this way. So it's all the real numbers for the x's. Domain is x, and so that's negative infinity to positive infinity, all of them. And the y's on this graph, as I go this way, is all the positive y's. As I go down this way, it's all the negative y's. So the y's are all real numbers. And it's the same, negative infinity to positive infinity. Okay, number 6, we have a array, so it's going in one direction. What direction? Let's see. Domain is x, range is y. Domain is x, so the axis, this point here is 0, this point here, x is 2, and y is 1. So the x is starting at 2. The x is starting at 2, and the x's are going to the left. As we go down, the x's are going 1, 0, negative 1, negative 2. So it's less than. And it's a hollow dot, so there's no bar. So that's it. And we started at a 2. And it's a hollow, not included. And we're going to negative infinity. Oh, there's negative infinity. Sorry, ignore that. And the y's are starting at 1. And also the y's are going, as we go on this line, going like that, the y's are 1, 0, negative 1, negative 2. So the y's are going negative. So that's less than 1. And there's no equal sign because it's open. It's a hollow dot. And so that starts at, if you want, that starts at 1, and it's going to negative infinity also. So check with your teacher if you can write it like this to make sure you're okay, if you are at the end of a notation. And that brings us to the end of the video. If you like my video, click the like button. And if you're not a subscriber, click the subscribe button and the notification bell because more videos are coming. Write a comment on my video if you wish. And visit my math website, www.mathfullyexplained.com. And there you get 3 sections. Me talks about my degrees and teaching experience. My video section talks about the strategies you're going to use to help you learn your math. The content section has the topics on my YouTube channel and the number of videos on those topics. And the black font is what's online right now, and the red font is what will be there in the near future. Thank you for viewing my video. Bye-bye.